moving on to next topic, that is laws of friction. Apparently this should be named as laws of static friction, right? Because these laws are applicable on the case of static friction. Generally it is said by this, laws of friction. So the first one states, these are 4 laws. First law states that the force of friction is directly proportional to the normal reaction. Okay, so whatever force of friction is applicable between two bodies, when one of the bodies is moving over another body, then the force of friction is directly proportional to normal reaction. Now what is normal reaction? The value of normal reaction depends according to situation and the body. For example, in this case, suppose this is a body of mass m, the weight is mg, so normal reaction R would also be equal to mg. But in case this body is placed like this, weight is vertically downwards, if the slope is making an angle theta, I can make 2 components of mg. One is this and one is this. This is theta, so this angle would be theta, this will be mg cos of theta, and this would be mg sin of theta. So normal reaction is always perpendicular to the surface, so R is equal to mg cos of theta. So normal reaction depends according to situation and the body. So excuse me. So this is the first law, that is force of friction depends on the normal reaction. Second law states that frictional force always opposes the motion in which the body is on the verge of moving over another body. For example, if, let me write it down for you, is always opposing the motion. That means the frictional force is always in the opposite direction of the existing motion. A body is moving over this body in this direction, so the frictional force would be in the opposite direction. This is what the second law states. Third one, that the law of the force of friction is independent of apparent area of contact. We have already discussed this thing in case of what is the cause of friction, right? So what is apparent area of contact? Suppose there is this body which is moving over this body. So apparent area of contact is this whole area. And what is the actual area of contact? The actual area of contact is one, it will depend upon actually the irregularities in the surface, because at the point of the joining of these two bodies, there will be some points where actual points of contact and the forming forces are formed, due to which the frictional force exists, right? So the force of friction is independent of apparent area of contact. Now we did not discuss this thing that day, that if we lubricate two bodies, we are actually filling up the gaps, right? So in that case the friction should increase because the real area of contact is getting increased. Why doesn't this happen? Or by polishing, even by polishing we are smoothing the surface, right? So by smoothing the surface, why doesn't the friction increase and it decreases? Because decreasing friction, there are methods of decreasing friction, and one of the ways is polishing. So I'll discuss it, just we are going out of this topic, I'll come back to that. Suppose we have two areas in contact like this, okay, and if I enlarge it on microscopic level, consider that these two bodies are like this. The irregularities, I am showing you the actual point of contact, okay. Now as we have discussed, I'll come over to the point of polishing in a while. As we discussed that the frictional force will increase by increasing the mass of the body, because if weight increases, the normal reaction will increase and hence force of friction will increase. So suppose I increase the weight of this body, what will happen? This thing will get converted into something like this, right? You have increased the weight, so these actual point of contacts have increased. That is why the force of friction increases, because normal reaction increases, right? This is what happens. So this is what we were discussing also that day, that at the point of actual contact, sometimes the bodies undergo plastic deformation, that means a continuous or a permanent change on molecular level, and they actually stick to each other. That is why frictional forces increase to very high extent. Now this is the point, that by increasing the weight we have increased the force of friction. Now what will happen if I polish this surface? By polishing, what we actually do, we decrease the actual point of contact, because when both the surface smoothen up, the surfaces are like this, okay. This is what happens after polishing. So after polishing, the actual point of contact decreases, and that is why polishing is one of the way of decreasing friction. Same happens with case of lubrication. Okay, lubrication will come in the next part actually. What lubrication has the effect on friction, that is covered in the fourth law. So the third law states that force of friction is independent of apparent area of contact. It depends only on the actual points of contact, right? So the real area of contact. That is not inculcated in the law. The law states only this much, that the force of friction is independent of apparent area of contact. Okay, I should write it down. Friction independent of apparent area in contact. The last law states that force of friction also depends on the nature of bodies in contact. For example, if I have a box made up of plastic, like a cubicle box, and I slide that cubicle box on this floor, it will cover some distance. But I have the same size of cubicle box made up of rubber this time, so it won't cover as much distance as the plastic box did. Why? Because the force of friction between the plastic and the ground is way less than the force of friction between rubber surface and the ground surface, right? So the difference in both the cases is the surfaces in contact. So friction also depends on type of surfaces in contact. So what do we actually mean by this? We are actually scientifically we are talking about two forces, that is cohesive and adhesive forces. Now if this term have just coined up, let's discuss this as well. We have to discuss cohesive and adhesive force. The adhesive force is the force of attraction between the molecules of different atoms or different surfaces. For example, we stick one paper with a plastic, so the surfaces in contact is paper and plastic, so these are two different materials. But if we have to stick paper and paper, these are of the same material, so that will cover under cohesive force. So adhesive force and cohesive force. Now for example, take a glass sheet or just a glass tumbler and drop a pour few drops of water on it. So the water will slide, but few droplets of water will cling on the surface, right? They won't completely slide down, so the water remains stick to the glass surface. But if the same thing is done with mercury, mercury do not cling to the glass. It will completely roll down without leaving any residue behind or any small the stickness behind. So the difference is the adhesive force between, in the first case, adhesive force between water and water, the cohesive force between water and water molecule, that means this cohesive force between water and water molecule was less than the adhesive force between water and glass molecule. So this force was stronger, this adhesive force was stronger, that is why it overcame the water and water molecular force, and that is why the water droplets cling to the surface. But in case of mercury, the cohesive force between mercury and mercury atom is way greater than adhesive force between mercury and glass. That is why mercury completely flows over the or just slides over the glass surface. This part is somewhere included in this law, that the frictional force also depends on the type of or nature of surfaces in contact.